vector representation. A vector in a plane is represented by a directed line segment, an arrow. So the end points of the segment are called the initial point and the terminal point of the vector. So here we have our initial point and our terminal point. So this has magnitude, a particular length, and a direction based on how that line is sloped. An arrow from the initial point to the terminal point indicates the direction of the vector, and the length of the line segment represents the magnitude. So we're going to use the notation let me go ahead and write that out. So these are more definitions, right? So the endpoints of the line segment, or the arrow, right? It's not a segment, it's an arrow. Directed line segment. Called the initial point and the terminal point of the vector. Vector, initial point, terminal point. All right, so the length of the line segment is the magnitude. Magnitude is our definition, is our vocabulary word. And the notation that we use is the absolute value of V. So since I can't bold my own personal text, I'm going to go ahead and actually put an arrow on top of my vector. So that's the notation that I'm going to use. So I'm going to go ahead and make that clear in my notes as well. So you guys are getting an unedited version of how I would really be doing this at home on my own, for my own purposes, right? Let me make this a little bit bigger, I think. Oops. So our notation is V, or bolded V when we're typing, right? Cool. All right, so a vector with an initial point and terminal point are the same, is called the zero vector. So we have a zero vector, and what that's saying is that we've got our initial point, and then we have our terminal point, and they're the same. So this is our zero vector. All right, so that's another vocabulary word for us. So a vector with an initial point and a terminal point being the same are called the zero vector. And once again, it's denoted with that bold letter O, right? Not letter O, number 0. So I'm going to use my zero vector notation, the same as I did up above. All right. So the zero vector is the only vector without a direction, and by convention is considered to have any direction convenient to the problem at hand. So that's sort of an interesting this side that we have here. So it has no direction, or whatever direction you want. Cool. All right. So vectors with the same magnitude and direction are called equivalent vectors. So we treat equivalent vectors as equal even if they have different initial points. Thus, if v and w are equivalent, we write bolded A equals bolded w. So here's our definition. Vectors are said to be equivalent vectors if they have the same magnitude and direction. All right, so this is even if they start in different places. Interesting. All right. So we've got some examples here, right, in figure 2.2. So vector v here is all of these actually. So in section B here, all of these are equivalent because even though they start all over the place, they all have the same length and they all have the same direction. So the use of boldface lowercase letters to name a vector is common in print, but there are alternative notations. When we're writing the name of the vector by hand, it's easier to sketch an arrow over the variable, right? So that's exactly what I've done here in my notation. And when a vector has an initial point P and a terminal point Q, then the notation that we use is actually PQ, which is useful because it gives us the actual direction that we're working with. So just a comment about notation. Vector V is equal to PQ if V has initial point P and terminal point Q. All right, so we've gotten our vocabulary down. Let's take a look at an example.